Hello, welcome to the next lecture on signals and systems. Here today we'll be dealing with some example questions, and we'll be covering operations on signals, and we'll be doing operations on the independent variable, which is time. Okay. So the first question is let x of n equal to x of n equal to n for odd n and 0 otherwise. Okay, this is n. So how will the signal be, right? For 0 we consider as 0, so it will be 0, and 1 value is 1, 2 it will be 0, 3 it will be 3, 1, 3, 4 it will be 0, 5 it will be 5, like that it will go. Similarly, and the negative side it will be minus 1, 0, minus 3, 0, minus 5, like, and so on and so forth. So if you remember from the symmetry part, this is, you can say this is an odd symmetry, this is an odd symmetry, right? So anyway, that's not a question. So the question is determine, actually this is not given in the question, I was just writing it out. Determine y of n is equal to x of 2n. Okay, I'm just writing the answer here itself. So y of n, right, let's draw this. So y of 0 is equal to x of 2 into 0, 0, so that will be 0. Y of 1 will be x of 2, which is 0. Y of 3 will be, 2 will be x of 4, which is again 0. Similarly, basically what is happening, we are just taking the even parts, even samples. So that is, this is y of n. Y of n is equal to 0 for all n. That is the answer. This is a time scaling, right? Here we are losing a lot of information. And the second question is x of n is equal to 1 for n is equal to 1, minus 1 for n is equal to minus 1, and 0 for n equal to 0, and more than greater than 1. This is the signal. Question is find y of n equal to x of n plus x of minus n, right? So I'm not doing much questions in continuous time, in the sense that some of the questions I'll be doing in continuous time and some of the questions I'll be doing in discrete time. So anyway, you will get a hang of both of these methods. Okay, so let's see a question. So x of n, sometimes the thing is that sometimes you can visualize the signal, sometimes you may not be able to, right? So if it is possible, it is always better to visualize the signal. So here you can see you have only two samples with non-zero values for n equal to 1 and n equal to minus 1. For all other values it is 0. So x equal to n is something like this. All other samples are zeros. So what will x of minus n be? What will x of minus n be? It will be 0. This will become minus 1, and this will become 1, and the other zeros don't change. If you add this, right, 0 plus 0 is 0, minus 1 plus 1 is 0, plus 1 plus minus 1 is 0. So the basically what you are getting is zeros, right, all zeros. So here also the answer is y of n equal to 0 for all n. Okay. So let's see the next question. Okay. Find y of t is equal to x of 2t plus 3. And our x of t is given as a single rectangular pulse, 0, minus 1, 1, 1. This is our x of t, this is t. Okay. So what was our idea behind our procedure for finding a signal when it has to be both shifted and scaled? The first step was shifting, right? First we had to shift. So here we have to shift 3. It is plus 3. The shift is plus 3. Plus 3 means it is shifted to the left by 3 units. The whole signal. So this is being shifted to the left means you have to subtract that value. So 1 will become 1 minus 3, that is minus 2. 0 will become 0 minus 3, that is minus 3, and minus 1 will become minus 1 minus 3, that is minus 4. So our shifted signal will be something like this: minus 2, minus 3, and minus 4. Value height won't change. So this is x of t plus 3. Okay. The second part is scale. Now we have to scale this signal. We have to scale x of t plus 3, right? X of t plus 3 we are scaling means we are multiplying this 2 with 3. Sorry, this t with 2, right? So let's see. That means this is greater than 1. So the signal will shrink by 2. The center won't change. This will become half, and this will also become, all these time points will become half, right? So what is happening? So instead of being from minus 4 to minus 2, it will become from minus 2 to minus 1. So it will be narrower, right? So it will be minus 1, minus 2, and this will be minus 1.5. This will be 1. It won't change. So this is x of 2t plus 3, right? Actually you can do this. This is our method 1, and this is the preferred method, because you can use this method to apply in what you say in this discrete domain also, right? And the next method I'll give an example how you can first scale and then shift, but do not do this. And this is preferred both continuous time and discrete time. Okay, so let's try method 2, that is scaling first and then shifting only for continuous time. Okay, so first scale. So our original signal was minus 1, 0, 1, 1. This was our x of t, right? So your scaling means you are taking x of 2t. So what is happening? It will be from 0, minus 1 by 2, 1 by 2, and 1. Okay. Now you have to shift, right? So the thing is that x of 2t, and you have to shift by some value, let's call it k, right? You have to shift by k, and this should be equal to x of 2t plus 3, right? So whatever shift you are giving here, it will be multiplied by 2. So the thing is that 2k should be 3, right? Therefore k should be 3 by 2. So this is a little bit tricky, in the sense you have to adjust for this scaling factor when you are giving the shift, if you are following this method, and that is why you cannot use this in discrete domain, because fractional shift will be there. Okay, so what you have to do, you have to consider x of 2 of t plus 3 by 2. That is what you have to do. Okay, you have to shift by 3 by 2, and you are shifting 3 by 2 to the left. So 1 by 2 plus 1 by 2 minus 3 by 2 is minus 1, right? It is minus 1, and minus 1 by 2 minus 3 by 2 is minus 2, and this is minus 3 by 2. 1, this is x of 2 t plus 3 by 2, which is equal to x of 2t plus 3. You will get the same answer as before if you check, and the thing is that you have to adjust for the shift. So in my advice, you better shift to you better stick to this shift first, then scale, right? I'll put some more examples for you to practice for this and the earlier type of question that we did. Okay, now let's try one question of shifting and scaling in the discrete domain, right? The question it was, no? Let's try one question here. X of n is equal to 1 for n equal to 1 and 2, minus 1 for n equal to minus 1 minus 2, 0 for n equal to 0 and mod n greater than 2, right? The question is, find y of n is equal to x of 2n plus 3. So we can do this graphically, and also even without drawing we can do. Okay, let's first what we do shifting, right? So let me just so we have to find x of 2n plus 3. That is what we have to find. So our first thing is shifting, right? So we have to find x of n plus 3. So x of n plus 3 is how do we do this? X of n plus 3. So x of n plus 3, right, is equal to 1. So earlier what did we do in discrete continuous domain? We just change, right, this time domain, minus 1 by 2. What we do, we subtracted my 3 by 2, right, the shift. So here also what do we do? 1 from n equal to 1 will become, what will 1 will become? 1 will become minus 2, because 1 minus 3, and 2 will become minus 1, 2 minus 1, right? Sorry, 2 minus 3 is minus 1, and for minus 1 it will be n equal to minus 1, and it will be minus 4, and minus 2 will become minus 5, and 0 will be for n equal to minus 3, and what? Now you cannot just simply write mod n greater than this 2. You know, you have to consider, right? And now if you see, it is having values from -1, -2, -3, -4 and -5. So n greater than -1 and n less than -5. That symbol value you have to be considered. So the original signal graphically also you can do. So the original signal, so let me just rewrite it properly, right? So this will be -2 and -1, right? And this will be -4 and -5. This will be -3. Let me see. So the original signal, if you draw x of n, it was 0, 1, 2, -1, -2, right? This was the original signal. So now what are we going? We are going to shift it to the left by 3. This is x of n. Right, we are going to shift it to the left by 3. So how do we do it? Just shift it, right? Simple. So anyway, the shape won't change, so we can just draw it like this and put the indexes properly. So +2 will become -1. This will be -2, -3, -4 and -5. So 0, 1, like that. -6. So this is in what alignment with what we did without using the image, right? So both ways you can do. So this is the shifting part. We are done with the shifting part. Now the second part is scaling. So scaling means we have to find x of 2n plus 3. We have already done n plus 3. 2n multiplying by 2 means we have to compress. We have to divide that whatever. You can always draw comparison with this one. So here we shifted. Then when we were scaling, what did we do? Even though we are multiplying 2t here, 2 here, in the time axis we are actually dividing. Whatever is there, we are dividing, right? So here also we will do the same thing. So this was from -2 and -1, right? For 1 it was from n equal to -2 and -1, right? So what will this become? This will become -1 and this will become -1 by 2. And for -1 it was n equal to, what was it? -4 and -5. N equal to -4 and -5. So this will become -2 and this will become -5 by 2. And 0, n equal to -3 and n greater than -1 and less than -5, right? So this will be what will this be? -3 by 2. And these values will change accordingly. So for convenience, let's just write it otherwise, 0 otherwise, because anyway we only need to know the values, right? So if you look at here, since this is a discrete signal, you can only take n values to be integers. So after scaling, what you have to do is, whichever n value is coming not as integers, you remove them. So this will go, this will go. So finally only these two will be remaining. So how do we rewrite this? X of 2n plus 3 is equal to 1 for n equal to -1 and -1 for n equal to -2 and 0 otherwise. Okay. So graphically, how do we do this? So we had initially found the value minus 1 minus 1. So this was for minus 3 minus 2 minus 1 minus 4 and minus 5, right? So now what do we have to do? We have to find x of this is x of n plus 3. We have to find what? X of 2n plus 3, right? So instead of going and finding each and every value for like substituting n equal to 0, 1, 2, minus 1, minus 2 like that here, we can just check from here which all values this because these are the values that we have as non-zero, right? We don't have any other non-zero values, so we can just directly map it to the new. So minus 1, it will be mapped to what? Minus 1 by 2. So we cannot take it. We'll just remove this. Minus 2, it will be mapped to what? Minus 2 by 2, which is minus 1. So we'll take it 1. Minus 3, it will be mapped to, and this will be minus 1. Minus 3 will be mapped to what? Minus 1 by 2, which is not possible. Sorry, minus 3 by 2 again, which is not possible. So we just avoid this. Minus 4 will be mapped to minus 2. So we have, sorry, this is minus 1, minus 2. And minus 5 will be mapped to minus 5 by 2, again, which is not possible. So out of these 5 values, only 2 can be mapped to the new thing. Again, similarly, like we mentioned, since this is greater than 1, we are losing values. So every other value will be zeros. So 0, 1, minus 3, minus 4, etc. Everything else will be 0. So this is again in alignment with what we got here, right? So this is how you do this complex operation of shifting and scaling together, right? First you shift, then you scale. That is the preferred method if you want to do for both continuous time and discrete time. If you want, you can do scaling and shifting, but you should be careful when you are giving the shift value. Okay. For discrete time, there is only one method, which is shift first and then scale. So I'll give some extra questions for all of these examples in the classroom. Okay, so with this I am winding up the different basic operations on signals. In the next lecture we'll be dealing with elementary signals, and from there we'll move on to the concept of systems. We'll like we had a detailed view of what signals are, and we'll have a detailed view of what systems are. Thank you.